Hello everyone, this is your Shital ma'am and welcome back to my YouTube channel. So today we are going to perform all logic gates using the Xilinx. So for that purpose we are using Xilinx ISE Design Suite 14.7. So we are going to perform here AND or NOT, NAND, NOR, XOR and XNOR gate. So let's start the video. Today we are going to design and simulate all the logic gates using Xilinx. So to perform the practicals on Xilinx, we need uh, one software, that is the ISE Design Suite 14.7. So here I am using the ISE Design Suite 14.7. So you can see here this is the logo of ISE Design Suite 14.7. So you just have to double click on that. Already I have downloaded this software. So we'll just double click on that. Now see, ISE project navigator will be open. You just have to click on OK button and go. So to create any kind of file or a new file, we have to go here, the file, then go to new project. Now see, this is your window. So create new project, specify project location and type. So here we have to enter the name of your project. So here we are going to perform what? That is the logic gate. So we'll write here logic underscore gate. Okay. So see here the location, see user logic gates. If you have to or if you want to change this location, so you can change from here. So we'll just create one folder, new folder, and we'll write here VLSI practical. Okay, so I'm going to save my file in VLSI practical. So you can change here the location by browsing here. Now see, this is the top level source type. So if you have seen here the schematic ADIF, NGC and NGO. So your top level source should be the HDL because this is the hardware description language. Okay. So click on the next button. Now see, this is the project setting. Now only you have to check here the preferred language. So your preferred language either Verilog or VHDL. So I am going to perform this practical using the VHDL. Okay. So we'll click here on VHDL. So my preferred language is VHDL. Next. Now whatever the contents we have selected or whatever the file name, project name, whatever the selected. So this summary will be shows here. Okay, so you just have to click on finish button. Now you have created here your project. Now see, you just have to, in the hierarchy, you just have to right click on that and go to the new source. Okay, now already we have selected the preferred language is VHDL. So you have to select here VHDL module. If you have selected Verilog preferred language, then you can select the Verilog, but have selected the VHDL. So we'll click on the VHDL module and we have to write here name. Okay, so I'm going to perform all these gate, that is the OR gate, AND gate, NOT, NAND, NOR, XOR and XNOR gate. Okay, so again you have to write the file name. So we'll write here the gate underscore file. Okay, so you can take any file name here. So this is the location. Now this gate 5 will be saved in the logic gate. So just click on the next button. Now see, this is the behavioral, that is the architectural name. Okay, so there are two types of architecture, that is the behavioral and structural. Okay, so I'm going to perform this practical on behavioral architecture. So now we need to perform any kind of gate that are the logic gates. We need the two inputs. So we'll write here A, these are input, B is input. So this is the direction in, out and in, out. So in in, that is the input. So we'll select here input. B is also your input. Now we are perform C, that is we can call it as AND gate for the output. C, D, E, F, that is AND or NOT, NAND, NOR, H and I. Okay, so what we are having the two inputs, that is A, B, C, D, E, F, G, H, I, J, that are your output. So this is for AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate and XNOR gate. Okay, and just click on the next button, and whatever we have selected the inputs and modules, so it will be shows in that summary. So just click on finish button. Okay, now see, these are the libraries. So we just have to write the code here. So this is the entity gate, whatever the port we have selected, so it will be shows here, that is the A, B, these are your input standard logic and these are your output standard logic. So we have AND gate 5. So architectural behavioral, if you have selected the structural, then it will be shows here the structural of gate 5. Now whatever we have to write the code, so you have to write this code in between this begin and end behavior. Okay, so whatever we have selected, now we have to write here. So how we can write, that is the C, this is your first output. So we can write C less than equal to, here we can write A and B, A and B. Okay, and don't forget to write the semicolon. Okay, so now next one, D less than equal to A or B. Then write the semicolon. Next one is E less than equal to not A. Not A. Okay, write the semicolon. F A and B, semicolon. G A nor B, again semicolon. H A XOR B, semicolon, and I is A XNOR B. Okay, so we have written all the gates output, and we have written here the logical expression for each gate. Okay, so in between begin and end behavior, you have to write these equations, or we have to write these logical gates. Now what we have to do, now we have to check this code. Okay, so just go to synthesize XST. So you just have to click on this plus button. Now you have to view the RTL schematic. So before that you have to check the syntax. Now do you want to save the changes? Yes. Okay. I want to save these changes. Now it will be in running process. So it will just check the syntax. Now see, process check syntax completed successfully, means there is not any error. Okay, if there is error, then it will be shows in this console window. Okay, now then go to view RTL schematic. So just double click on that. Now see, you just have to write, click on start with a schematic of top level block and then click on OK button. Okay. Now see, whatever the we have selected here, inputs and output, it will be shows here. Okay. So these are your inputs and these are your outputs. So you can see this is the block or output C, output D. Now, if you just double click on that, then you will get the internal structure of that gate. Okay, means what? These are your input. Okay, so this is your AND gate, OR gate, NOT gate, NOR, NAND, XOR and XNOR. Okay, so whatever the gates we have selected or whatever the outputs will be there, it will be shows here. See, GHI. Okay, so these are your output. Now we have to run the simulation. So you have to go for the simulation part. You just have to click on that. Next, just click here on your file. Then it will be shows here ISIM simulator. Just click here. Behavioral check syntax. Just click on that. So first of all, it will be check the syntax and now go to simulate behavioral model. Now see, the next window has been opened here. Now here we have to see your inputs and outputs. Okay, whatever the waveforms will be there, it will be shows here. Now we have to give some inputs and output. It may be either 0 or 1. So just for A, right click and go to the force constant. Okay, now see here force to value starting at time offset and cancel after the time offset. So if you have given only the value, it may be a 0 or 1. So first of all, we'll write here 0. Okay, then click on apply, click on OK button. Then next one is the force constant. We'll give here the 0, apply, OK. Okay, so we have to run this. Now see, there are lots of applications or options we can see, run all and run for the time specified on the toolbar. So we'll just click on that run button. Now see, the color has been changed. Color, first color it has shown in the yellow and now it has been changed in the green color. Okay, so you can see here, if your inputs are 0 0, so for AND gate, C is what? That is your AND gate. Your output is 0. This is your output for the OR gate. So 0 0, it will be 1. This is your NOT gate. Okay, so whenever it will be 0, your output will be 1. Okay, so same like that, whatever the outputs will be there, it will be shows here. Now if I want to change the output, we'll just write again on the force constant and we'll write here 0 and B is 1. Okay, again we'll rerun this. Now you can see whenever you are giving 0 1, your AND gate will be 0 and OR gate will be 1. Okay, so we'll just click here. See, zoom to full view, you just have to click here. Then you can see all the inputs and outputs. So see, this is the 0 0, and whenever you are giving the 0 1. Now again I have to change here, that is 1 0. Okay, so go to the again force constant 1, go to apply, okay, and here I have to give 0. Okay, again we'll click on this run button. Now see, 1 0. You can see here, this is your 1 0, and whatever the output will be there. See, for the AND gate, if you are giving 1 0, here you will get the 0. And whenever you are giving 1 1, so here C should be 1. So last one will write, go to force constant, again we'll write here 1, go to apply, again here that will be also 1, go to apply button, okay. Okay, so again we'll click on this rerun. Now see, AB is 1 1, your AND gate is 1, OR gate is 1, and this one will be 0. So according to that you can check your truth table here. Okay, now you can see this is the 1 1, this will be the 1 1. Okay, so according to that it will be changed here. See, this is 0 0 0 1. See here 0 1. Now see, here is 1 0, and now you can see here is 1 1. So this will be your truth table. So according to that truth table you can check your outputs here using that waveforms. Okay, so I hope you understand this logic gates, how to perform these logic gates using the Xilinx software. So if you like this video, so please don't forget to share this video to your friends. And if you have any doubt, so please give me a comment in the comment section. And please don't forget to like, share and subscribe my video. Thank you.